Hey, welcome back. Today we are going to go over the last portion of this unit, and that is the colligative property of freezing point depression. It is identical to boiling point elevation, only instead of how much does the boiling point raise, this is going to be how much does the freezing point decrease. Okay, so the second half of the sheet is basically talking about freezing point depression. So I want to go over question number 11 and question number 12 with you. Like I said, they are identical to 1 through 10, but it's still worth going over them again. This is a multi-step problem. The more you practice, the more you're going to be efficient at it, the better you're going to be at them. So question number 11 says, how many grams of silver would have to be dissolved in 1,120 grams of ethanol to lower the freezing point by 0.25 degrees Celsius? The Kf for ethanol is 1.99 degrees Celsius per molality. Now, if I'm taking a look at this again, I want to look at what am I being given, what do I have, and how do I try and get to where I want to go. I want to know grams of silver. So somehow I have to figure out what are my moles of silver going to be. Well, I know that by using the triangle for molality, molality is moles over kilograms. And I have my kilograms, but I don't have my molality. However, I know by using the other triangle that molality is going to be delta TF divided by KF. So molality is my delta TF divided by KF. Just like yesterday when delta TB was divided by KB, delta TF divided by KF is going to give us molality. I know that my delta TF is 0.25 degrees Celsius, and I know that my KF is being given to me, and that's 1.99 degrees Celsius per molality. This is going to give me my molality, and it comes up to be 0.13 mole unit. Okay? Now, step 2 is to find the number of moles of solute, silver, using the molality that I just found. So moles, and I have to use the other triangle, is going to equal molality times the kilograms of the solvent, which is right here. So I just calculated my molality to be 0.13, and my kilograms of solvent is 1.12. Now remember, it's in grams in the question, so I divide it by 1,000 to get my kilograms, and that ends up giving me 0.15 moles of Ag. The last final step that you have to do, and everyone should know how to do this, is I'm going to take my 0.15 moles of Ag. 1 mole of Ag is 107.9 grams of Ag, and I end up with approximately 16 grams of silver. So if I wanted to lower the freezing point of ethanol by 0.25 degrees Celsius, I would have to take 16 grams of silver and dissolve it in 1,120 grams of ethanol. Let's go to the next question. What is the freezing point depression when 85.3 grams of oxygen is dissolved in 1,500 grams of water? And again, it gives us the Kf for the water, which is 1.86 degrees Celsius mole unit. So now what I'm ultimately trying to find is what is delta TF. I know that delta TF equals my molality times my Kf, but I don't know my molality yet. So my first step is to figure out what is the molality of the solution. So initially, to find molality, it's moles over kilograms of solvent. I don't have my moles yet of my solute, so that is actually going to be step 1. Find my moles of solute. So I'm going to take my 85.3 grams of oxygen because that's my solute. And I'm going to go ahead and convert that over. 85.3 divided by 32 gives me 2.67 moles of oxygen. Okay? After I have 2.67 moles of oxygen, I then have to take my moles of oxygen and find my molarity. To find my molarity, I'm going to take moles over kilograms. 2.67 moles of oxygen over 1.5 kilograms of water. Okay, remember it's 1,500 grams, so that's 1.5 kilograms. 2.67 divided by 1.5 gives me 1.8 molality. The last step is to figure out what my delta TF is going to be, and that's molality times KF, and my molality is 1.8, and my delta or my KF is 1.86 degrees Celsius molality, and that gives me 3.3 degrees Celsius. So you can see that it's identical to what we were doing with elevation. We're just going freezing point instead of boiling point. Again, any questions, let me know. I will talk to you guys all soon.